This is part 2 of a 2-part video. To catch up on what you missed in part 1 where we took a look at particles, interactions and allotropes, there's a link in the card up here. Hello everybody and welcome to the Science of Minecraft part 2, where we're going to take a look at gravity and some astrophysics, answering the big question, can Minecraft's Earth be a cube? So last week we took a look at gravity as a fundamental force, and how it doesn't really affect particles due to it being so weak. This time we're going to look at how gravity impacts significantly larger masses, such as planets. It may surprise you, but everything has its own gravitational field, from objects as big as the Earth to the smallest parasite, and if not for how weak our gravitational field strength is, then we'd actually be able to work it out, using some simple equations. However, we can find out the gravitational field strength of our Minecraft Earth. If we want to find out the gravitational field strength of our Minecraft world, then we'll have to do a quick practical. The easiest way to figure out the strength of a gravitational field is to use a free fall equation. In this equation, h is the distance you fall from, t is the time you fall for, and a is your falling acceleration due to gravity. The first thing we need to do is to change the equation so that acceleration is the main focus, because acceleration will be equal to the gravitational field strength of the world. Okay, so we know that every solid block in Minecraft has a volume of 1 meter cubed. So for this practical, I built a tower 10 blocks high, or 10 meters high. Then in Minecraft, I did 3 concurrent drops and calculated the mean average fall time, which came out as 830 milliseconds or 0.83 seconds. So now we have our height and our falling time, and we can put these figures into our rearranged equation. From this, we know that acceleration due to gravity is 29 meters per second, or 29 newtons of gravitational force. So there we go, the gravity on Minecraft's Earth is 3 times higher than our Earth's. There are multiple reasons which could cause Minecraft's Earth to have a stronger gravitational field than our own. One theory is that the planet is much denser and has much more mass than our Earth, and this would mean it would have more mass stuffed into the same volume of space. The other option is that Minecraft's Earth is simply much larger than our Earth, which would mean that it would have a greater mass than our Earth, and as such gravity would be stronger as well. But either way, the main takeaway is that the gravitational field strength of Minecraft's Earth is significantly higher than our regular Earth. This brings us on to our big question for the episode. Can Minecraft's world be a cube? Well, to answer this, we need to know how planets are formed. In order to do this, we're going to take a look at our own planetary system, the solar system, named after our sun, which is named Sol in reference to the Latin word solis. Let's go back to the beginning, 4.5 billion years ago. At this point, all that existed was a giant cloud of hydrogen gas, the most basic element in the universe, and a large volume of dust. The hydrogen gas is pulled to a central point by gravity, bringing the gas molecules close together in the middle of a nebula, and it begins to spin, until it gains enough energy to cause the hydrogen gas surrounding it to combust, creating the solar system's protostar. So there we are, our solar system now has a star. A pretty puny one, but a star nevertheless. Now all we need are some planets. The planets get formed differently to the sun, as you might expect. The remaining gas and dust left over from the formation of the sun flatten and come together to form a rotating planetary disk. This spin creates a gravitational field around the disk, which keeps in rocky particles if they collide with it. Now, you may be wondering, why does it spin if gravity pulls particles to a central point? Well, it's due to a conserved quantity called angular momentum. This was caused by the Big Bang, which gave angular momentum to large clumps of matter when they were thrown out from the centre of the universe. These clumps broke down and then go on to form galaxies and solar systems, and this even explains why all of the planets in our solar system rotate in the same direction as the sun. They were all formed from the same gases and dust as the sun, and as such have the same initial angular momentum. Anyway, this extra mass increases the gravitational field strength of the disk, and allows it to attract even more particles. These particles come together and contract to form planetesimals. These collide with one another to become larger. At the same time, the free gases in space freeze and form giant balls, which then go on to build gas giant planets like Jupiter and Saturn. And it's this force of gravity which results in the Earth getting its spherical shape, as gravity pulls all matter into a central point. This means that even if the Minecraft world were to start out as a cube, over time its corners would be pulled into a central point to form a sphere due to the influence of gravity on such a massive object. So there we go, Minecraft's world unfortunately could not be a cube due to the influence of gravity. But we're not done with planets today. When you look at the planets in our solar system, you can see something interesting. Starting from Mercury and moving further from the Sun, we find that planets closest to the Sun such as Mercury, Venus, Earth and Mars are rocky, followed by the gas giants of Jupiter and Saturn, and then the planets furthest away are the ice giants of Uranus and Neptune. There are many theories as to why they get distributed like this, but the most prominent theory is that they got pushed away by solar wind. Solar wind is the name given to the flow of plasma which emanates from a planet's star. It's thought that when the planet was a new protostar, then these winds would have been far stronger than they are currently, meaning that they could push the lighter elements like hydrogen and helium away from the inner orbits. And then once in the outer orbits, the gravity of the outer gas giants drew in those elements, creating solid cores of rock surrounded by ice surrounded by gas. So there we go, that's effectively how planets were formed and why planets range from gas giants like Jupiter to rocky planets like Mars and the Earth. But what about Minecraft's moon? Is there any possibility that that could be a moon as seen in game? Well, fortunately, the moon is actually way simpler to explain when compared to the Earth. Moons are what are known as natural satellites, and these come in a variety of different sizes and types, with the only planets without moons being Mercury and Venus. Before the Apollo space mission's research, there were three theories as to how the moon was formed. The first was capture theory. This suggested that the moon was a wandering body of rock and dust, like an asteroid. The idea was that this body was formed somewhere else in the solar system, and when passing Earth got captured by our gravitational field, and then began its orbit. After this came accretion theory. This suggests that the moon was created at the same time as the Earth. And finally, there's fission theory, which suggests that the Earth spanned so quickly that some material broke away from the Earth and began to orbit it. Nowadays, of course, all of these theories have been replaced by giant impact theory. This theory suggests that the moon was formed during a collision between Earth and another planetary body the size of Mars, and the debris from this impact started to orbit around the Earth. The evidence from this theory came from the Apollo space missions. These collected rocks from the moon which showed that the Earth and the moon had significant chemical similarities. This evidence supports collision theory in particular, as if the moon had been created elsewhere and was captured in the Earth's orbit, then the materials that make up the moon and the Earth would be significantly different. As it is, the only difference is that the minerals found on the moon contain less water than any Earth rocks. The current explanation for giant impact theory occurs during the early days of Earth's history. During this point, it's speculated that a Mars-sized planet called Theia collided with the Earth. During this, Earth and Theia merged to form one new planetary body, and then a new mass spun off from the Earth to form the moon as we know it. Now, although this does mean that technically the debris could have been a cube, if very unlikely, you still get the slight issue of gravity causing the corners of the cube to flatten with time, as gravity pulls them to the centre of the moon to form the sphere that we see at night. So there we go, a planet can't be a perfect cube due to the effect of gravity pulling all matter into a central point from a very early stage of planetary development. And although the moon theoretically could be a perfect cube, it's incredibly unlikely and definitely wouldn't last long if it somehow happened. Thanks for watching. If you enjoyed this video, then don't forget to like and subscribe. And of course, if you have any ideas for me to cover in future videos, then put them down in the comments down below. I'll consider all of them. But until then, this has been the Science of Minecraft. I'll see you next time.